Let's take a look at number 5 from 4.1b lesson. So we have 3x minus 2y equals 2, and 5x minus 5y equals 10. So I need to figure out what I want to eliminate. It's not easily done to go from 3 to 5x or from 2 to 5. So I'm going to have to pick either one. They're both going to require multiplication of both equations. That way, we can end up with a certain number of x's or y's that are going to cancel out. I'm going to work with the y's. So here I have a negative 2y, and I have a negative 5y. So the least common multiple that I could get to would be 10y for both. That means I need to multiply this top equation by 5, and I end up with 15x minus 10y equals 10. Then for the second equation, I need to end up with a positive 10y in order to add these and be able to eliminate the y's. So in order to get to 10y from negative 5y, I have to multiply by negative 2. Negative 2 times 5x is negative 10x. Negative 2 times negative 5y is positive 10y. That's exactly what I wanted, so I can cancel those out. And that equals negative 2 times 10, which is negative 20. So when I do elimination, I add these equations together. 15x minus 10x is 5x. Negative 10y plus 10y, it's going to be 0y. I officially eliminated those. Equals 10 plus negative 20 is negative 10. In order to solve for x, I'm going to divide out the 5 from both sides, and x is negative 2. Now that I know what x is, I can plug that into my original equation. Either one is fine. I'm going to work with the first one because the numbers are smaller. X is negative 2. So I'm going to plug that in as x. 3 times negative 2 minus 2y equals 2. So I get 3 times negative 2 is negative 6 minus 2y equals 2. I'm going to add 6 to both sides to get the y's alone, and I get negative 2y equals 8. Still have to get y alone, divide out negative 2, and y equals negative 4. Now I have x and y, so I can write my solution, or point of intersection, as a point, negative 2 comma negative 4. Let's look at number 6. So I'm trying to figure out what I need to multiply one equation by in order to eliminate either the x's or the y's. So looking at the x's, one doesn't easily turn into the other if you multiply it by something. The least common multiple would be 99, that's pretty high. But for the y's, the 5 can actually become 15 if I multiply this top equation by 3. If I want to end up with a positive 15y, because this is a negative already, I need to multiply it by a negative 3. If you're still not understanding that, watch when we multiply through. So we end up with negative 3 times 11x, negative 33x, negative 3y minus 5y, positive 15y, equals negative 3 times 80, which is negative 240. The second equation can stay the same, 9x minus 15y equals 120. And I use elimination. I'm going to add these two together. Negative 33x plus 9x. It's going to give me a negative 24x. Then I have 15y minus 15y. This is why I wanted this to be positive, so when I add a positive y and a negative 15y, I eliminate the y's because I get 0y. Equals negative 240 plus 120, that's negative 120. Now I need to divide out negative 24 to get x completely alone. And negative 120 divided by 24 is positive 5. Now that I have x is 5, I can substitute it into either equation. I'm going to choose this bottom one. 9x minus 15y equals 120. So x is 5. 9 times 5 minus 15y equals 120. So 45 minus 15y equals 120. I need to get y alone, so I'm going to subtract 45 from both sides. Negative 15y equals 120 minus 45, which is 75. I'm going to divide out negative 15 to get y completely alone. Y is negative 5. So I have x and y, and I can write it as a point, 5 for the x and negative 5 for my y. That's the solution where these two lines intersect. And number 7. So to start, the first question you should ask yourself is, can I easily get from the one x to the other or one y to the other in order to eliminate the variables? So the x's, can I easily get from 4 to 3 or 3 to 4? No, there's nothing I can multiply it by to get to the other. What about from 7 to 2 or 2 to 7? No. So I'm going to have to multiply both equations by something in order to end up with a number we can eliminate. I'm going to work with the y's because this already has a negative and this already has a positive. So I know if I get them to be the same number, they'll be eliminated. The least common multiple between 2 and 7 is 14. So I have to multiply this first equation by 2 to get a negative 14y, and this one by 7 to get a positive 14y. So when I distribute, I get 8x minus 14y equals 20. In my second equation, I get 21x plus 14y equals negative 49. By doing elimination, I add these equations together. 8x plus 21x is 29x. Negative 14y plus 14y, that's 0y. I eliminated the y's. And then equals 20 minus 49, which is negative 29. So when I divide out 29 to get x alone, x is negative 1. Now I use substitution. After elimination, we do substitution. So take that x is negative 1 and substitute it into either equation. I'm going to choose the first one. X is negative 1, so 4 times negative 1 minus 7y equals 10. Negative 4 minus 7y equals 10. I'm going to add 4 to both sides. Negative 7y equals 14. Divide out negative 7 from both sides. So I end up with y equals negative 2. I now have x and y, so I can write it as a point, negative 1 comma negative 2. For number 8, you need to write a system of equations that could best be solved by using multiplication first, and then eliminate to solve. Exchange your system with another student in class to solve and find the solution to your system. When done solving, exchange your system with another student in class to verify and check the solution. So for your system of equations, you're going to have something x and something y equals a number for two equations. In order to set it up so that you need to multiply first, whatever number you have here, let's say you have a 2, please don't use my example, make this a multiple of 2. So you can make this 8. And then the y's can be any number. So if you set it up like this, you can choose any numbers. Please use different numbers than me. When your partner gets their paper, they know they need to use multiplication first to get this 2 to be a negative 8. So they would know to multiply by negative 4. Please set up your own system of equations. Switch papers to solve, and then switch again to verify.